Greetings to everyone in a fitting manner. This is the last part of the series, at least for now, but I will tell the details in the video. First of all, I feel I should mention OSHV Lab and OSHV Lab Stars and jump to their webpage for a quick look. So on the OSHV Lab Stars webpage, you can find the details of the event, and also there are a few questions already answered which should be checked before you apply. And now back to the video. The closing part of the series will be the Home Assistant part of the system. First we go through the NodeRED part and then the dashboard. Then I will share some experience with the actuators and another with the Honeywell TA6R thermostat, which is cost almost €200. Okay, so first of all, before we jump into the NodeRED part, I must show you these input numbers, which are the actual required temperature parameter for the heating system. Every room has one set temp, and every set temp is configured the same way from 20 to 28 degrees, and I also have 0.1 degree steps. We have finally arrived at the NodeRED section. The top section is where I move the previously introduced set temp input values into individual flows. These flows act as variables, making them reusable through the heating tab. Make sure that the output on connect option is enabled in the state node. Then, in the change node, I transfer the payload to the flow specific to each room. In this last room, I experimented a bit with hysteresis, but eventually decided it doesn't really make a noticeable difference, so I plan to revert the change at some point. The next part deals with the TRVCs and the dashboard display setup. The state node monitors the temperature reported by the Zigbee temperature sensor placed in each and every room. If the measured value remains lower than the set point for over 10 minutes, the execution continues on the top true path. If the condition is false, the bottom false path is followed. The branches controls the opening and closing of the room's TRVCs, which, just like explained in the previous video, is actually toggling a monochromatic light on or off. Another key part is sending a true-false value to the binary sensor associated with each room. I will talk more about this in the dashboard section, but for now, what is important is that I created these binary sensors in NodeRED, and using the NodeRED companion add-on, the entity becomes accessible in Home Assistant, just like any other native binary sensor. You may also notice that some rooms have two radiators, such as the living room. Also, here I keep track of which actuator is normally open and which is normally closed, as they need to be controlled in reverse. At the end of this section, you will see the remaining 3 battery-powered thermostats, which I plan to replace after some wiring work. For now, though, I'm focusing on the outdoor projects and garden work. You will see more on that in the next series. The next noteworthy part of the setup is the master switch for the heating system. This is also a NodeRED based entity. Its current state is passed into a flow, so I can use its value later in the logic. Finally, we have arrived at the last section. In the top branch, a decision will be made based on the series of binary sensor values. If none of the room requires heating, for example all sensors are false, the flow checks whether the boiler is currently running or not. And if it is, it gets turned off. This shutdown process can be triggered from 2 additional sources: the master switch directly, or, as you can see, by a scheduled task that runs every 5 minutes. Turning the boiler on is a bit trickier. First, after a scheduled check, I evaluate the master switch status. If it is on, but the boiler is off, I then assess the state of the binary sensors. Since NodeRED operates asynchronously, I don't have the access to all the states at once. The solution here is a join node, which waits for the predefined number of messages and combines them into an array in our case. That array is passed to a function node, which runs the following simple JavaScript logic. It loops through the array, and if any of the binary sensors were on, it returns on in the payload, otherwise it returns off. If the resulting payload is on, I will turn on the boiler and set the target temperature to 35 degrees Celsius. The next part which I would like to show you is my Home Assistant dashboard. This is the current production one, which is used by my wife and by myself. Here you can see the rooms, a calendar, some state icons at the top, but there are a lot of more, but those only shows up if it's active, for example my door and window sensors. You are able to set the temperature in every room subpanel with ease, as you can see here with the living room, but I like to have an overview of the whole system. The screen is divided to two columns. In the top of the right one, it's my office/workshops heating part, which is separated from the house, and since I have a lot of screen around me, my wife started calling it as NASA Center, hence the name in Hungarian. With the TRVCs, we are interested mostly with the left column. The first item is just displays the Zigbee thermostat current state, which controls the gas boiler directly. The main switch, as the name implies, is the switch which can disable all the automation and the heating in the house. The next part is where I can see all the room actual temperature, I can set the desired temperature, and I also have a status information from the binary sensor, which I also mentioned in the NodeRED section. The only noteworthy part of this screen is the summary graph, where I can check the rooms, and I also have a gas burner status from the gas boiler itself. So I was just about to start recording the NodeRED part of the video when I realized that my Honeywell thermostat is fucked me up again, because your heating must go through some remote fucking servers, and of course the API went nuts again, so I had to do something about it. Actually, this behavior was the third time when it happened, and I promised that the second time that either I will replace it in the summer when the heating season is over, or if it happens during the heating season, I will drill the hole in the wall and install the already bought Zigbee-based thermostat for the gas boiler. When I realized it, it was around midnight, and of course I will not start drilling at midnight because of the kids. But when I get up in the morning, one of my first tasks was that I pull up my drill and drill a new hole for the new thermostat in the wall. The whole job was around an hour with everything, but after I installed the new thermostat, I realized that I have installed it in the thickest wall in the house, and inside this wall, the Zigbee network is just lost. There are Zigbee devices all around it, which works as routers, and the coordinator is just the top of it with one level difference. But inside the wall, the thermostat actually not get any signal from the coordinator or any routers in the neighborhood. Because of this, I had to do a quick and dirty, which you can see here, and it definitely not stay in this state, but I will wait the heating season, and after it I will figure out something. Possibly an external junction box will be used, because I cannot put it inside the same wall from the other side, because it will be the same outcome. So yeah, I really hope that the external junction box will solve my issue, and I'm just glad that my heating system works completely locally from now. So about the actuators. As you can see, I have a few of them, and unfortunately they are no longer work. But let's take a step back in time. My initial plan was to use a normally open version. The main reason behind this was that the valve inside the radiator tends to get stuck if it stays closed through the summer, and I also wanted to avoid unnecessary power consumption from the PoE switch during the summer just to keep them open. Unfortunately, this idea turned out to be flawed because the selected actuators couldn't even handle staying closed, meaning under constant power during the heating season, since the radiators are usually not heating the rooms. From the first batch of the normally open actuators, only one type is still working today in the kids' room. Surprisingly, this one seems to be the cheapest, yet it survived the first heating season. Since then, I've started favoring the normally closed types because they seem to be more durable. Inevitably, this means I will have to deal with moving the valves in the summer to prevent them from getting stuck. So soon I will put together some kind of automation that will run when the heating main switch is off and open the closed valves once or twice a day for a few minutes or so. Unfortunately, I can't say for sure how long the last working normally open actuator and the new normally closed will last, but if I will continue this series later by replacing the remaining battery power thermostats and expanding the wiring, and or after getting through the next heating season, I will share my experiences. Naturally, everyone purchased their preferred valves at their own risk, but the above might help others choose the good or at least the better option from the start. So please don't forget to like, share and subscribe and hit the notification bell. And you can also support me on Patreon, or you can buy me a coffee or some electrical gadgets. Thank you. Bye bye.